All right, this is Honors Algebra 2 Pre-Calc. We're doing partial fraction decomposition in Chapter 6 / partial fractions, which is actually the 2.7 section in the Pre-Calc book. So we're going to do the partial fraction decomposition for this lovely monstrosity. So remember, the very first thing before we do anything else is we have to factor the denominator. So I'm actually going to inch over here and do that where I have a little bit more space. So this is going to be a factor by grouping problem. I look for a GCF. There isn't one. It's not a binomial. It's not a quadratic trinomial. But when I try grouping, it does work. So I'm gonna factor by grouping this. So if I take this x cubed plus x squared plus 2x plus 2, if I group the first two and the last two, right, I can take a group GCF of x squared out of the front two and be left with an x plus 1, and I can take a plus 2 out of the second two and be left with an x plus 1. So this factors into an x plus 1 times an x squared plus 2. Right? Cool. So I now know that those are my two factors. So an x plus 1 and an x squared plus 2, right? Again, it's a prerequisite to do these problems that you're able to factor them, but that doesn't mean that it's easy to factor. So if you feel weak at factoring, you need to kind of go back and revisit those skills. So because the first factor, the x plus 1, is linear, I'm going to get an a on top of an x plus 1 plus, and then because the second factor, the x squared plus 2, is quadratic, I'm going to need a bx plus c on top of that factor, okay? So that's my setup, right? Again, remember, if you can't get the setup, you're going to have trouble doing the rest of the problem. So focus on making sure that you get the setup right based on the rules in place, right? That's my setup. So now my next step after the setup is to get a common denominator that is exactly identical to my original red denominator. So what that's going to look like, this x plus 1 fraction already has the x plus 1, but it's missing the x squared plus 2 on the top and bottom. So I'm going to times by x squared plus 2. Similarly, this x squared plus 2 fraction already has the x squared plus 2, but what it's missing is the x plus 1 on the top and bottom. Now, a thing to note is that bx plus c is a binomial, and that entire bx plus c is getting multiplied by the quantity x plus 1. So what that's going to mean is now everybody has the same denominator. X plus 1 times x squared plus 2. X plus 1 times x squared plus 2. X plus 1 times x squared plus 2, although in the reverse order. So now I essentially only need to worry about my numerators. Right? And we've talked in other videos about how if it makes you feel more comfortable to pretend you're multiplying the entire fraction by that denominator, that's great. I don't care. So 2x squared plus 3x plus 10 equals a times the quantity x squared plus 2 plus, in parentheses, bx plus c times, in parentheses, the x plus 1. Okay, so here we go. Now, that's my whole equation. Now, you can use clever substitution here. What I'm going to point out is that if you choose clever substitution, right, if you choose a -1, you'll be able to knock out not only b, but also c, right? By choosing x as a -1, it'll knock out this entire expression and let you find a very easily. Similarly, if you choose x is 0, it's going to knock out b only, but since you already know a, knocking out b would be enough information for you to find c. Then you could pick pretty much any x value that's not -1 or 0, plug it in, and since you know a and c, you'd be able to find b. And that's fine. Okay, that is one totally acceptable option. Another totally acceptable option is to FOIL everything out, clean it up, and then use that idea of the left-hand side and the right-hand side being equal to make a system of equations. It doesn't actually matter to me which one you pick. I am going to walk you through both options. Again, you would never do both. You would pick one. Sometimes you'd pick a combination of them, but you would never do the work to find A twice. You'd never do the work to find B twice. That's just not worth it, okay? An interesting option that you could pick that's a combination of these is, as I said, you could find A very easily by knocking out both of these. So you might find A first and then choose to do the thing where you distribute everything and say the left-hand side equals the right-hand side, because then you already know one of the numbers, and that's totally fine. So I'm going to start with some clever substitution. I'm going to notice that I could use -1 to knock out the entirety of this expression. So I'm going to do some clever sub and plug in x as -1. If I do that, I'm going to get a 2 times a 1, so 2, minus a 3, because 3 times -1, plus a 10 on this side. Over here, I'm going to get an a, and then this is going to be a 1 plus 2, right? Because -1 squared plus 2 is a positive 1 plus 2. And then plus a whole bunch of 0, because this x plus 1 term is going to get knocked out. So I'm going to end up getting that a 9 equals 3a, so it looks like my a is 3. Now, as I said, that's pretty straightforward, and I'd suggest just busting that out right away, because now you officially know that you can replace this a with a 3 forever and always, right? So now you're at a point where actually a really smart option might be to do that other plan, that left-hand side equals right-hand side. It's up to you. I would also argue it's pretty easy to find C, right? If I were to plug in 0, right, if I plug in x is 0, it's going to knock out only the b, nothing else. So by plugging in x is 0, I can find C pretty fast, right? Because if I plug in 0, I'm going to get 0 plus 10 on my left-hand side. On the right-hand side, I know this is a 3 now, so that's a 3 times a 0 plus 2. Plus, in parentheses, 0 plus C all times what seems to be a 1, right? 0 plus 1. So I get 10 equals 6 plus C. Seems to me that my C is 4. Right? So that, and actually I'll give myself a little more room. So my argument is that it wasn't hard to find either A or C. It's kind of a pain to find B. The reason it's hard to find B is that there's nothing, I mean, it would be hard to find B if you didn't already have A and C, because there's no good way to knock out the A term without using an I. The things that would get rid of this factor would be a plus or minus the square root of 2 times I, which is not fun for anybody. So the last thing I'm going to do is I'm going to pick literally any x ever that is not these two, and I'm going to use it to find C. So again, what this let me do, right, this let me find A, I don't mean C, I mean, sorry, it'll let me find B. This let me find A, this let me find C. So now I'm going to pick any other easy x. Right? It has to be not those two. Well, the only other easy x I can think of that isn't those two is x is 1. I mean, also 2 is fairly friendly, but 1 is really nice. So if I do that, I'm going to get, oh, and remember, just like I noted here that A was now 3, I now know that this C is forever and always a 4, right? So, seems to me when I plug in 1, I get a 2 plus a 3 plus a 10 on this side. On the other side, I'm going to get a 3 times a 1 plus 2. Plus, in parentheses, b is unknown, but b times 1 is a b, plus 4, times what seems to be a 2. So, I get a 15 equals a 9 plus 2b plus 8. So I think when I subtract the 9 and the 8 over, I get negative 2 equals 2b, and I get that b is a negative 1. So that's one way to do this, and then once I've done all that, I'm going to go back to my original. So over here, I'm going to write the answer, right? So my answer to this problem, right, my answer is going to be A, which was the 3, make sure you get it right, so the 3 on top of the x plus 1, plus negative 1, because that's my b, times x plus 4 all over this x squared plus 2. Now that's a great answer, totally fine. You don't have to write the negative 1, you could just write it as a negative x, that's fine. There's always somebody that says, why can't I put the negative here and make this a minus? You can, but this is that situation I talked about previously when I said you have to be careful if something is a binomial, because if you yank this negative away from the x, you're also taking it away from the 4. So another totally acceptable answer would be a 3 over x plus 1 minus this x, but now it's an x minus 4 because you factored the negative out of both the x and the 4, right? And that's also fine. I would suggest that this answer is good, and I'll be honest, I'm probably not going to put the 1 in front of the x. I'm probably just going to make it a negative x, right? I would suggest this answer is better because, again, it cuts down the possibility for making a stupid mistake. Now, I am going to walk you through the other way to find A, B, and C. And you can decide for yourself which one you think is better. They both have pros and cons, and it's also not a situation where one of them is always better than the other. In different problems, sometimes you start doing clever substitution and you find yourself kind of miserable about it, and then after a little bit, you instead switch to doing the other option and realize how much easier it is. Other times, the exact opposite is true, right? Okay, so I'm going to pretend I didn't find those values, and I'm going to walk you through the other way to do it. If I distributed and cleaned everything up on this side, I'm going to get an ax squared, right, plus a 2a. When I FOIL this, I'm going to get plus a bx squared plus a bx plus a cx plus a c. Now, that looks kind of messy, but if I put everybody together based on their like terms, it seems to me that I have ax squared and a bx squared, right? Those are my x squareds, right? For the x's, I have a bx and a cx, right? Those are the x's. And for my constants, I have a 2a and a c, right? So that has to equal the 2x squared plus 3x plus 10. Now, I'm going to argue that this is one of those problems where it's not worth it to do it this way. It doesn't turn out nicer. Sometimes it does. So using this method, what I'm saying is that the left-hand side has to equal the right-hand side. So the highest power I have on either side at all is an x squared. So the x squareds on the left-hand side are 2, and that has to equal a plus b, because those are the x squareds on the right-hand side. My x terms on the left-hand side are just 3x, right? And on the right-hand side is b plus c. And then lastly, my numerical term is a 10 on the left side and a 2a plus c on the right. Here's the problem with this system of equations. It's totally solvable. You have three variables, a, b, and c, and you have three separate distinct equations. It is solvable. But what's annoying about it is that none of the three actually share the same two variables that you want to get rid of. So there's a couple different ways to do it. I would argue one way to do it, right? So one thought that you could have is that you could, for instance, do something like the first equation minus the second equation. Because if you did that, the b's would essentially cancel, and you'd end up with an a minus c, and then you could do elimination. So what I'm going to do is I'm going to take my x squared equation minus my x equation. So I'm going to get a 2 minus 3 on the left-hand side, so it's a -1. And on the right-hand side, I'm going to get an a minus, there's no a, so it's still an a. B minus b goes away, and then I would subtract the c. So I'm going to end up getting -1 equals a minus c, which I could now do, use the third equation, the 10 equals 2a plus c. I could do elimination really easily on that equation, right? I could add straight down, and if I did, I'd get 9 equals 3a because the c's would cancel. So I'd get a is 3. Right? And once you know a is 3, you can back substitute to find all the other ones. Since a is 3, you know that 2 equals 3 plus b. Oh, look, b must be a -1, right? And since a is 3, you know that 10 equals 2 times 3, which is 6, plus c. Oh, look, c must be a 4. So again, I get the same three values, it's just a different way of doing it. Don't pick both options, that's a bad idea. Now, I will point out though, remember how easy it was to find a in the first part? When I found a the other way and I found very quickly that a was 3. Well, if a had been 3 in both of these equations, I would have found b and c really quickly. So there are definitely some benefits to mixing and matching the solutions methods, but you know, you have to find what works for you.